Okay, I'm Alan Johnson, KU2Y, and this video introduces the satellite tracking and telemetry decoding software that is built into the ARISS Radio Pi. So we're running our Raspberry Pi here with the ARISS Radio Pi software. You can see the desktop here, and the two programs I'm going to talk about are GPredict, which tracks satellites, including the ISS, the International Space Station, and various AMSAT CubeSats, and FoxTelem, which is a piece of software that AMSAT uses to decode telemetry for their currently on orbit satellites. So let's go ahead and start here by double-clicking on GPredict. We could also access it by going under the Raspberry here and selecting it. It basically tracks all the different satellites. You can put in different ones. The default set is a set of interesting radio amateur satellites. Now, one of the first things you want to do when you run it is go into Edit and say Preferences, and click on Ground Stations, and it defaults to AMSAT's headquarters in Kensington, Maryland. So you want to double click on that. You can call it whatever you want, put in your address, latitude, longitude, or grid square. Right? The only way it can track satellites over your location is if it knows your location. So you should do that, and then say OK. The other thing to do, you could say OK, is to go under Edit here and say Update TLE from Network. So TLE stands for two-line element. But really what that is current up-to-the-minute information about satellites on orbit. So it's information about where they are and when and what height and how fast and all that. And this data gets updated every couple of days, and it will be out of date unless you've run it in the previous day. You need to do it. So you click on that, and it's downloading all the data and says it's finished. So now you have accurate information. If you forget to do that, you might be like, oh, this satellite's going to be overhead, and you'll listen and you won't hear it because it might have been overhead 20 minutes ago, or it might still be coming. So this shows the map of the world here with your location shown here, and then the various satellites, their footprint is shown. So the footprint represents the part of the Earth's surface that can see the satellite, that basically has line of sight contact with it, so that in theory you could transmit a radio signal to it or receive from it. So you see right now there's actually no satellites over, but SO50 is actually just about to come over, or it's just left. I can't tell. But we can also see here, for example, AO91. AMSAT Oscar 91, also known as Fox 1B, it's currently below the horizon. See, the elevation there is set to minus 44 degrees. Here it is here. It's basically over the South Pacific, just to the east of New Zealand there. But it is rising, and it will eventually come overhead. And GPredict will tell you. In this case, it's saying that the next one on the list here is AO73, AMSAT Oscar 73, and that will be in 33 minutes. That will be coming over the horizon. So what can you do when a satellite or the ISS is overhead? Well, you can tune the radio and listen if you know the frequency. The other thing you can do is you can try to decode telemetry from it, and telemetry is basically digital data about the status and health of the satellite. So let's run the software called FoxTelem, which is used for satellite telemetry by AMSAT. AMSAT has a bunch of CubeSats on orbit, and this software is used for tracking them. It's called FoxTelem because the current series of satellites are known as the Fox 1 series of CubeSats. So FoxTelem is the Fox 1 CubeSat telemetry software. So when you run it here, You can see across the top it lists the various AMSAT CubeSats, AO91, AO92, AO95. It also lists the CubeSat simulator, which is another whole topic, and it also lists some future CubeSats, including Fox 1E. And if you look over here under spacecraft tracked, you see that it actually knows that AO91 is below the horizon, right, minus 42 degrees. Just like GPredict knows, FoxTelem also knows. And again, it's based on your location. So if you want that to be correct, you need to go in here to settings and either set it using your grid square or by setting your latitude and longitude. And one cool thing about FoxTelem is that if you leave it running, it can automatically turn on, track, and decode telemetry from the satellites as they fly over. So you can do that by clicking on this auto start checkbox here, and it says decoder will start automatically when spacecraft is over the horizon. Now you do need a good outdoor antenna to pick up satellite signals. They're very weak, they're very far away, and so if you have a small indoor antenna, you won't get anything. You do need an outdoor antenna and a decent view of the sky that isn't blocked by buildings and thick trees and things like that. So there's none overhead here, so we can't listen to any, but we can check out the CubeSat simulator that I have running here. So to do that, I can select the RTL SDR. So it can use, FoxTelem can basically tune it as a radio automatically, which is very convenient. And I say start. And yeah, we can see here is a signal. So this is kind of like the spectrum we were looking at before, and there is the peak. And here, this is the signals that it's decoding. So this is a binary signal. It's either a 1 or a 0, depending on whether it's high or low. So it's just a whole series of 1s and 0s that turns into numbers. This is known as an eye diagram, and it's used by communication and radio engineers to determine how good a digital signal is. And you want to have a nice open eye, which is what this is. So there's no lines through the middle. If I tune somewhere like here, right, where there's no signal, that's a closed eye pattern, because you see it's basically just random noise. But if I click here on the signal itself, it locks in and we get this nice open eye. So now I can go under the CubeSat Sim tab here, and you notice this telemetry payloads decoded count should be increasing. Yep, it just went from 8 to 9. And the various data is populated here. So for example, I can double click on temperature here. And so this is the CPU temperature of the Raspberry Pi inside the CubeSat simulator. Currently 67 degrees, so pretty toasty. That's 67 degrees Celsius. So yeah, but you can see the data is being updated in real time, and the data points are getting plotted here. So if you have a CubeSat simulator, or if you wait until the actual CubeSats are over the horizon, you can use FoxTelem to decode the telemetry and get information about it. Now this does require the RTL SDR to be plugged in, and if it happens to get unplugged, then you're going to get a whole bunch of error messages like this. So this one says USB, so that's the hint. Well, it says perhaps device removed. That's pretty that's pretty helpful. And plugging it back in does not fix the problem. You basically just have to restart FoxTelem. So I'm just going to X out of here. I can close that too, and I can run it this time by double clicking here, and it should come up this time. And there it is, and we're running just fine. Okay, well, I hope you've enjoyed this look at tracking satellites and decoding telemetry from satellites using the ARISS radio Pi.